Hey Klein ISD Pathway Explorers, my name is Jerome Bowser. This is Stephanie Borg. We're so excited today because she's going to talk to you about geology. Take it away, Stephanie.
Come on, explorers, let's get aboard. Geology is the study of what makes up the Earth, the history of the Earth, and how Earth changes over time. Geologists study and work in a wide variety of fields that include many parts of the Earth and Earth's history. This includes the deep ocean, water that's underground, Earth's climate, erupting and extinct volcanoes, glaciers, minerals and crystals and caves, energy sources, and fossils of ancient life. These scientists study how these parts interact with each other and how they can affect each other. They can look at how things were in the past by looking for clues in rocks, like fossils, chemicals, or even movement that help tell a story, and can help us predict what might happen in the future. Being a geologist is sort of like being a detective. You have to look at the evidence and then figure out what it's telling you. There are some basic rules about how rocks form that all geologists have to understand to do their jobs. For example, geologists know that rocks that are closest to the surface of the Earth are the youngest rocks, and generally the deeper you go, the older the rocks are. Another rule says that rocks usually form horizontally, laying flat. So if they aren't horizontal, something must have happened to them to make them that way. Geologists can tell how the rocks moved in the past by figuring out which way the rocks are tilted or folded. Did you know that rocks can fold? It takes a lot of pressure and heat to do that, but that's how many mountains form. If you find something going across a rock, like a crack, it must have gotten there after the rock in the background had already formed. Some of these rules sound pretty straightforward, but geologists have to understand how rocks behave under certain conditions to understand and figure out how the rocks they're looking at today got to be that way. This is a way of explaining the structural parts of Earth's history. Geologists have a lot of different jobs. Some stay at school for a long time and do research to find out more about the Earth. Other geologists go to work in big companies, like the energy companies we have in Houston, and help find and safely transport oil and gas so we can have electricity and drive our cars. Petrologists and volcanologists sometimes travel to observe what the Earth's crust is doing at volcanoes or at the bottom of the deepest parts of the ocean. The crust is the outermost layer of rocks on the Earth. Paleontologists use fossils to tell the story of ancient environments and the populations of living things that once lived on Earth. Hydrogeologists can use rock formations and water movement to help detect where pollution might be coming from. Glaciologists help tell the story of Earth's climate by looking at chemicals trapped in glaciers, and can find hints on rocks that glaciers were once in a place that may be warm today. Seismologists study movement in the Earth's crust, like earthquakes. They can tell by looking at a seismogram how much the Earth shook during an earthquake. They can also figure out where an earthquake happened by looking at where people felt the shaking. Stratigraphers figure out what the layers of rock are in different places and can tell what the area used to look like if there were rivers or lakes where it's now dry, or deserts where there is now a forest. These are only some of the many jobs that geologists can have. Studying geology can get you outside and more familiar with what has happened in Earth's history and how the landscape you know was formed over a very long time. It can also help you understand how those same processes that formed what you see now will continue to change the Earth long after we're gone. And besides, who doesn't like to collect cool-looking rocks and minerals anyway?